Hi, welcome back to my channel Daily Code Dive. So today we'll be covering this topic level or order traversal. So now, what is level order traversal? Okay, with the name you can imagine what exactly it is. That here we are traversing each node level by level. Okay, so let's suppose here we have this tree. Okay, I'll take this example of this tree. Here, if you can see, let's suppose this is level 1. Okay, and this is level 2 and this is level 3. So what we will do in level order traversal, we'll first cover all the nodes which belongs to the same level. So here if we are traversing, we will first cover the node which are present at level 1, that is 1. Then after that we will go towards level 2. Now in the level 2, how many nodes you can see? That is 2 and 3. So after that we will cover level 2 nodes, that is 2 and 3. Then after that we'll move towards level 3. And how many nodes we have to level 3? That is 3 nodes, right? We will cover it one by one. 4, 5, 6. Okay, and also how we will basically cover the node, we will move forward left to right. Okay, so it's like 1, 2, 3. So we are moving, you can see, moving from left to right. From here also we'll first take node 4, then 5 and then 6. So we are moving towards left to right. So we are moving towards left to right. So this is basically level order traversal. So now if coming to the algorithm part, how we can implement level order traversal, it's actually very easy. Like the other traversal which I have explained, pre-order, post-order or in order, right? There we were basically using stack, right? So here we will not use stack, here we will use queue. Now how we'll be using queue and why I'm saying we will use queue, that also I'll explain. So now if let's suppose if I'm traversing through this binary tree. Okay, so what basically I want in my result list. So this is result list. In my result list, what I want, that is first 1 should come. Okay, then 2, then 3, and going forward the other nodes which belongs to the other level. Okay, so what I want a container, any container. Okay, I want a container when first I'll push 1 in that container. Okay, after that I will push 2. Okay, after that 3. Now how I wanted to store the result in the result list. I want first element. So let's suppose this is any container. Okay, this is any container. So what I want, after inserting 1, I want 1 inside my result list. Okay, then after that so after that I have placed 2 and 3. Then I wanted to remove 2 as well after 1. Okay, so that is here. Then after that, yeah, when I'm removing 2, I will also add the child member of 4 and 5 here. Okay, so after 2 is removed, I have add 4 and 5 child. Then after that I will remove 3. I will place it here in the result list, and then the child of 3 as well, that is 6. And then so same thing we will do for the other child as well, 4 and 5 and 6. So if you can see, this is not stack, right? Because in stack what we were doing, we were removing the first element present in the stack, the top element. But if you can see here that we are inserting it, we are inserting one by one, but we are removing whatever element present which we have added at the first place. Okay, whatever element we have placed in the first place. You can see similar like 1 in 2 and 3, which is the first element, that is 2, which we placed, right? But while inserting, we are placing it inside the front. So this is the property of queue, right? Hence we will be using queue data structure here. So I hope it is clear that why we are using queue data structure, and with the help of queue data structure we can easily implement it inside the code. Okay, so now for the I'll explain it. I will explain it here. How we gonna implement it in algorithm. Same thing which I have explained. Okay, so let's suppose I have a queue. I have taken one data structure, queue data structure. Okay, so what I will do, I will basically, first thing what I will do, obviously I will check whether root is equals to null or not. If it is null, then obviously the result list will be empty. Otherwise what we will do, we will place the first element 1. Now after placing one element inside the stack, what we will do, we will have a while loop where we are basically checking if whether queue is empty or not. Right now it is not empty. What the first thing which we will do, that we will take out 1 from the queue, we will place it here inside the result list, and then we will take its right child. Okay, sorry, its left and right child. So we will place it here 2 and 3. We have removed 1 now. Okay, after placing 2 and 3, if 2 and 3, so next thing what we will do, again we will remove the element from the front. Okay, and we will place it here inside the result list, and we will add its children, that is 4 and 5. Now 2 is also removed. Same thing we will do. 3 will also remove from here. We will place it inside the result list, and then we will add its child 6. Again 4 we will also remove. Now you can see 4 does not have any right or left child, so we will not add anything. After that we'll move forward to 5. Same thing, 5 we have removed it. Same thing with 6 as well. And yeah, so now at this point you can see the queue is empty, and this is the time where our loop will get stopped, and yeah, we get the result list. So this is the level order traversal, where we are traversing level by level through each node at certain level. So basically this level order traversal will be very useful when we are calculating height of the tree. Implement this. Let's take one lead code problem. There I will explain you the same thing which I have explained here, the algorithm. I'll basically explain you that in the code as well now. Okay, so I hope I'll be able to explain this. Okay, so now here I have taken one level order traversal question from lead code. So I'll be explaining here like how whatever things I have explained in algorithm, the same thing I'll be explaining here. So one by one I have already implemented this algorithm in the code. So here first thing which I have explained, that we'll be using queue data structure. So this I have defined one queue. Then after that I have defined a vector which will store the result list. Then the first thing which I have told before even starting, that first we will check whether root is equals to null or not. If it is equals to null, then we will simply return the empty result list. Otherwise what we will do, we will push the root node inside the queue data structure. Then we will take the while loop, and this while loop will run unless the queue becomes empty. So what we will do here, we will take the front whatever we have stored inside the queue, we will basically take the front element from the queue, and we will push that node value inside the result list. After that we will remove that element from the queue data structure, and then the next step will be, we will basically push its left and right child if they are not equals to null. So this whole loop will continue unless the queue becomes empty. Once it becomes empty, then we will return the result list. So this is how we will basically implement the level order traversal. You can see, right, it's very easy and similar to the pre-order traversal. There we were using the stack instead of queue, and here we are using queue data structure. So yeah, that's it about the coding part of the level order traversal. I hope I was able to explain this properly. So yeah, let me know if you have any other good solution for that. So yeah, thank you so much.